So, today we are looking at special right triangles. So, yesterday you learned about the Pythagorean theorem and how we relate that to triangles, and the converse of the Pythagorean theorem, which lets you use it to determine whether triangles are right triangles or not. Today we're going to look at some special cases for special right triangles. And these are things that often come up on things like the ACT, and we can also use them later on in geometry to help us easily make some conclusions. So, the first type of special right triangle is an isosceles right triangle. When my first son was born, I tried to convince my wife that we should name him Isosceles because it is a dude's name from way back, long time ago. But she said no, and also everybody angle. There we go. Also, everybody who I asked about that said that's a terrible idea, so we didn't do it, but oh well. So an isosceles means that you have two legs that are congruent, and a right triangle means that you have 90 degrees there. And so we call these legs, and I'm going to use L for legs, and we call this hypotenuse, because, well, we always call that hypotenuse, but the word leg is usually used with isosceles triangles. Okay, so what can we say about this? Well, we can say that a squared plus b squared equals c squared, which means leg squared plus leg squared equals the hypotenuse squared. Now, this is a special situation because these two numbers are the same, so we could also write this as 2l squared equals h squared. And now, if we want to know the hypotenuse, we take the square root of both sides. So square root both sides, and what you find out is, well, the square root of h squared, those are inverse operations, so that is just h. That's just the hypotenuse. And the square root of 2l squared, it's important to notice here that this squared, it's just with the l. So the square root of 2l squared is the same as the square root of 2, here let me draw that all the way over, the square root of 2 times the square root of l squared. You can break up products of radicals or square roots like that. And the square root of l squared is just l, and the square root of 2 is like, where's my calculator? I'll show you. The square root of 2, second square root of 2 is a weird number. 1.4142. It's an irrational number. We can't express it as a fraction or anything. And so we're not going to write it as a decimal. We're just going to leave it as the square root of 2. But the square root of l squared is l. So the rule that we want to remember about isosceles right triangles is that the hypotenuse is the square root of 2 times l. So if I know that, then I can save myself some time. So if I'm given some triangle and I'm given that the leg is, let's say, how about 7, or any number, well, we know that these two are congruent because the little marks. So this is also 7. And if I want to know the hypotenuse, well, I can use this formula right here. The leg is 7, so h equals root 2 times 7, which we just leave like that. I don't even have to do any calculations. I can just write in what the hypotenuse is. It's just the length of the leg times the square root of 2. So try a couple of those, and then we'll look at how you solve it if you're given the hypotenuse and you want to find the leg.